Welcome back to the Danish Board of District Heating and our podcast series. In this podcast series, we invite experts from the industry to highlight important developments. The goal is to inspire, to learn, and maybe also provoke some new thinking and some actions. I mean, provoking in a positive way. Many times, and again today, we will focus on how to reduce carbon emissions in our industry. This time, we will focus on very large heat pumps. Of course, not the small individual ones. They are not important to us. But the one that has become an important part of the heat production in recent years in many district heating networks. Maybe not today, every day, but very often I read about new plans on implementing large-scale heat pumps from pretty much any source I can imagine, at least. Outside Denmark, I end up in talks about heat pumps again and again. And it's a great little machine, well, a great big machine, and we need more of them. No doubt about that. This time I would like to focus on the really large heat pumps. How they can support our aim to decarbonize and become an important player, even in large cities. Copenhagen has recently announced their plans to build 700 megawatt heat pumps capacity, and the two largest heat pumps has been said to be more than 100 megawatt each, so they will matter. This is the Danish Board of District Heating podcast, and I'm Morten Hjort Dudal. Today I have two guests here, two experts on heat pumps. One is Claus Nielsen, who's Director of Business Development for Forsyning in Esbjerg, and the other one is Raymond Decorvet, Global Business Development person in MAN Energy Solution from Switzerland. Claus, welcome, and maybe you'll introduce yourself and the project a little bit, and then we will ask Raymond to do the same.
Yeah, thank you to be here today. I'm glad to be invited. I'm Claus, as you said. I have been working with green transition of the district heating in Esbjerg area, because we are not only covering Esbjerg, we are part of two municipalities, so we're covering the cities of Esbjerg, Varde, and also Tjæreborg, close to Esbjerg. So we are around 27,000 houses or buildings supplied with heat from our district heating network, and around between 19,000 people are getting their heat demands supplied with the solutions from Forsyning here in the west of Denmark, close to the Waddensee. We are in the middle of decarbonizing because we are getting rid of one of the few last coal-fired power plants here in Esbjerg. And we are now doing this transition directly from coal-fired CHP into electrifying our heat production by utilizing heat pump technology. Our heat source is seawater. And now I will lead the word for other person.
Yes, good. Raymond, thank you. Claus. Raymond?
Yeah, thank you very much. Good to be here. Thank you very much for inviting me. Yes, as Claus said, I'm in global business development for heat pumps here in Zurich at MAN Energy Solutions. And I'm doing this job with passion already since 2018.
Good. Thank you very much. Claus, we have 3 or 4 coal-fired plants in Denmark, and suddenly the coal-fired plant in Esbjerg has to be taken out of operation. There was things happening because of the energy crisis and so on, but now you're really focusing on this heat pump. I understand 66 megawatt. It grows a little bit, but that's just an interesting little perspective. Can you talk us through the project? What did you do? Why and how, and what were your considerations?
Oh my God, there were a lot of considerations because this project is not a completely new thing. We are hopefully finalizing this year to get the first heat out of the heat pump system to our grid this year. Probably the end of May, we hope. But the thinking about this was already starting in 2014, when we had to do a transition plan for the coal-fired power plant. And in 2017, we saw that there were only two options, either to convert the power plant, the coal-fired power plant, to a biomass-fired CSP. And we thought already at that time that there could be an alternative when you are on the West Coast, where you have the most renewable electricity generation in Northern Europe, at the West Coast, where you have the most outbuilt renewable offshore wind. So we tried to find a way to fit into this more renewable electricity system. And since 2017 until 2019, we were fighting about the allowance to get this approved as a concept, because we were still into this electricity laws in Denmark, where you have to have centralized electricity production, and therefore also centralized heating use, that you have to use the heat from the centralized power production. But we managed to get an exception to the law in 2019, and then we started to develop the project in really detail. And then we found out it was the best alternative for us to use seawater as the heat sink, and for that to utilize the energy from the seawater and put it into the district heating system, we were looking for heat pump technology. And that were giving us the possibility to do a tender process where we were looking for invention out in the market, because there were not mega heat pumps in big scale, and the installations were there from the 90s, where there were other refrigerants allowed than it's today. So we had a need, and we needed some new technology, and we started a public tender about this. And luckily, we saw that there were some potential new technology developments going on in Switzerland.
And maybe, Raymond, that could be a lead to you, because you are on that side. You're building the heat pump.
Yeah, absolutely. And we are not an awful long time in heat pump business, but we have a very long history of many decades in producing compressors. Best technology compressors, which we are using in many other applications. And we are now using exactly the same compressors for our large-scale heat pumps, but I would like to promote the term mega heat pumps. Why? Because large scale, we don't want to be thrown in the same basket like other large scale 2, 4, 5, 10 megawatt. But our mega heat pumps, we go well beyond the 20 megawatt up to 50 megawatt with one single heat pump string. So we would like to promote a new term called mega heat pumps. And using these new and high technology compressors, of course, we thought, hey, it's a good idea actually to enter this growing market with heat pumps. And I think it's funny, we started in about early 2019 when we promoted our CO2 heat pump. First time ever, I think that was my perception. We claimed that we can do 150 degrees of hot water using CO2 as a refrigerant, doing 50 megawatt of thermal output. And I think that was really appealing for many people. And obviously also for the Forsyning. So they found us, we didn't find them. And so then we collaborated, we exchanged our ideas. And so finally it came to the decision so that we got awarded for this project end of 2020. So after roughly 2 years in business, we already won this major project, which we are very proud of. And so this is how everything happened.
I need to understand, and maybe other people out there understand much better than me, but you say up to 50 megawatt, and Claus said, I think 66 megawatt. But that's because, Claus, you have 2 heat pumps. Can you, in a few sentences, make it clear to me what we are talking about? What is the size?
Yeah, the size is thermal output of 66 at a lot of details, because it's a lot of details into this. It's not like boilers where you have a fixed amount of heat thermal output, because it's really depending on district energy, the district heating network temperatures, the temperature of the energy source, and also how to operate it also against the electricity grid. Because as we have not talk so much about today, it's not only one technology. We see it as like a portfolio thinking, because we have to have a flexible thermal power generation. So we have to fit into the environment, both on the energy sources, but also into the energy system in total. So that was also one of the key benefits. We had a really flexible heat pump technology. We have 2 lines, and again, 2 lines, Morten. Each of them is 33 megawatts thermal output in reference conditions, and in them, we can optimize them on temperature levels, on thermal performances, but also, and not at least, on grid integration with the electricity grid, because that's also really important for us. When you fit into the energy system, we have to provide balancing. One of our key advantages in our portfolio thinking with this technology is that we can help the electricity grid, the electricity system in absorbing more renewables, because you can be much more flexible on the demand side by using mega heat pumps, because you can provide huge flexibility, and you can also provide grid stabilization to the electricity grid, and that's also a key benefit for our solution here in Esbjerg.
Yeah. And there is something interesting, when the people from the Forsyning were asking us, how quickly can you ramp up your system? In how many seconds? And this question we didn't understand in the very beginning. So we made some tests, we made some estimations, which we actually then confirmed in a factory acceptance test in 2022 it was, in summer. Actually, we can ramp up because of this compressor technology, which is quite special. Maybe we come to that. We can increase the electricity input within less than 30 seconds by 8 megawatts. And actually, this is something very important and interesting also for this grid balancing, what Claus was just talking about. But they had to teach us actually why they have been asking how quickly can you ramp up or go down into part load actually. So we know better now, and this is a very interesting USP we got now with our compressors.
Yes. Maybe we should touch a little bit on the compressor technology, Raymond. Can you give a few more details on these things? You mentioned it before, and I think it's very interesting that listening to Claus and his team, you said, okay, we need really to provide evidence that we can ramp up, and that will be my next question to you, Claus. How much do you going to use that? Ramp up, ramp down, and what does it matter to your economy? But let's start with the technology, Raymond.
So the compressor we are using is called Hoffing. This is a high-speed, oil-free compressor. which has an integrated motor. The motor actually is cooled by the refrigerant itself, which flows through the compressor. The compressor is completely sealed, and this is happening and possible actually because it runs on magnetic bearings. So there is no shaft which is going out of the compressor, which needs to be sealed. So it can be closed from both sides, so it completely hermetically sealed. It's running on magnetic bearings and doesn't need any lube oil. And because of that, the control of the system, we can really ramp up fairly very quickly. And I'll give you an example also about the stability and the ruggedization of this solution. Two of these large compressors actually are standing at the bottom of the North Sea, 300 meters below sea level. And because they are completely sealed, they are doing the job down there with no chance actually to make any maintenance. And they are running there since September 2015, so many years. Actually, they have been brought up a couple of weeks ago. Then we looked into that, and they look new inside, I was told. So we closed it again, and we already brought it down again, and now they are running for another couple of years, hopefully without any interruption as before. And this is the kind of technology which we are very proud of. The next project, actually, where we are doing the same subsea compression, will be in Australia, where we bring 5 of these units below sea level, which is about 1,500 meters or 1,200 meters, I'm not quite sure. But so anyway, it will be another challenge. But yeah, this is what we can do with these kind of compressors.
Good. Claus, never done it before. Were you not a little bit nervous? Such a big heat pump, man, however good they are at compressors and everything. Didn't you take a deep breath before you signed the contract? Or?
Yeah, we did a lot of deep breaths, I would say. but the alternative was, for our case, much worse, because we had a really hard task to solve, because the problem was we needed to find a way where we have a portfolio where we are not utilizing biomass CHP. So we wanted to have an electrified heating production. And the alternative heat pumps also had a lot of problems, both on refrigerant sides, but also on durability on the compressor, because there's at least 2 main things involved when you are talking heat pump technology: refrigerants and compressor technology. And they are also linked into each other, these 2 things. So that was really what we saw, the less bad alternative at this point, because, as you say, it's a new thing. The compressor type was quite unsure. It was not shown before in this application, but we saw some strong application from other industries that we believed in. We also had a lot of discussions and also guarantees from both from MAN but also from the mother company, because the MAN group is owned by a bigger group, an international German group, and we were quite keen that if we have to go on a new path where there's issues about technology and we can be aware that there could be some issues to be handled during this travel, we were pretty sure that having a strong partner that have the willingness to go all the way, that was important for us. And that was also one key thing for us, to have the strong commitment from the group CEO and also from the board representative, from the owner of the Man Energy Solution Group, because we believe that we will not be alone with a project that we had to finalize ourselves. So we knew that we have a strong partner, both on technology but also on financing, that had the will to go all the way. That was important because we know that there would not be a smooth travel all the way because it's new. But also, if we have chosen some of the alternatives, they would also have been on new investigations, because we were at the first, at least in Denmark, in these modern district heating networks to integrated mega heat pumps or really big heat pumps. Nobody have done that directly into a network where that have been running on burning on CHP, because there's a lot of other things. How well your district heating network is ready for integrating heat pumps. So you really have to have a good network and network operation on the district heating part. So the old skills of being an operating company is really important also to do this journey.
Yeah, but I have to admit we have been confident in our competency in regarding handling gases, including CO2. But Claus is right. I mean, that was our first heat pump project, and we did a lot of other projects, as the one I just described with the subsea compression. That was also a one-off. We did it. And for making also and to confirm actually that we can do it, that's why we performed a factory acceptance test in 2022, and that was a great success. That was a kind of a project within the project where we actually really confirmed that we can do what we promised to the Forsyning, and we even overachieved what we have promised to them. And now we are installing these two heat pumps on site, and so we are.
And trust me, Raymond,
moving.
In a year or two, when we have the proper results and some operational experience and something, I'll remember what you just said, and then I'll come back to you in a new podcast, and then we can talk about the real results of where did it go and how did it work with the electricity market and so on. I'll remember that one for sure. But it's fine. I appreciate that it has been a long and hard process, and it looks like in a few months you'll get the heat out of it. Raymond, you said a word I haven't thought much about, but you said mega heat pumps. Say a little bit more on that. Of course, you mean really big ones, but what do you see? What is the perspective for Europe? Talk a little bit about heat sources. Elaborate on what is a mega heat pump.
Yeah, a mega heat pump, well, any definition, goes from here to there, but you can argue on that.
Yeah.
But currently, what I see in many of the conferences I go, people start talking about large-scale heat pump, and then they mean a 1 or 2 megawatt heat pump, which is certainly a large heat pump, but not really a mega heat pump. Mm-hmm. And there are some other suppliers. We are not the only one who are really dealing with these mega heat pump beyond 20 megawatt and so on. And they are most and best suited actually for district heating. I think district heating is still in baby shoes using heat pumps, particularly these large heat pumps. But these are the low-hanging fruits, because a lot of district heating networks are run even beyond 100 degrees, 120, 130 degrees even. And up until now, heat pumps could not provide these high temperature levels. So that the only possibility to run a high temperature district heating network was fossil fuels. And now the heat pumps, they can do this job. And that's why we have to get rid of these fossil fueled heat sources for district heating networks as quickly as possible. And I really believe these are the low-hanging fruits also to meet the CO2 targets. Why? Because you just replace a heat source with another one, with a heat pump, which is completely decarbonizing the heat. Not only the heat, you also can get cold out of it, which you can use for somewhere else, for cooling, for instance, a data center, which is hopefully nearby. So we can do sector coupling with all this stuff. With the mega heat pump, you can build thermal storage to better use the surplus of renewables, which is on the grid as well. So that gives you all this flexibility, actually, and this is all going towards a green solution, towards making the heat and the power transition. And I think mega heat pump is a very, very good technology, the best technology I can imagine right now.
But my question went in two directions. Now you have said 50 megawatt, 33 megawatt, 66 megawatt is kind of maybe a baby mega heat pump, a small mega heat pump. How large do you think we will see heat pumps in the future?
Well, see, the output of a heat pump has something to do also with the calculation. This is a COP, the coefficient of performance.
Yes.
Right, and we achieve here in Esbjerg a COP of roughly about 3.3 in winter time. And imagine we are taking out cold seawater in winter at maybe 2 or 3 degrees. We only take 2 Kelvin out of these 2 or 3 degrees seawater, and we lift it to 70 or even 90 degrees, and we have a COP of 3.3. And this is the magic of CO2 as a refrigerant, because it gives you that flexibility beside other things. And I mean, this is great performance. And now you have this COP, which is maybe 3, which can be much higher even in certain circumstances, depending on the heat source you have. And you multiply it with the electricity input to the compressor. And that gives you then roughly the thermal output. So if we have even bigger compressors, not Hoffings, but other compressors which we also build in our company, then maybe we have an electricity input of 40 megawatt.
That's 120, 30 megawatt.
Exactly. So this is possible, and not out of reach. And I think district heating networks are really, really looking for these kind of large heat pumps in the future.
Good. Enough about Esbjerg and din Forsyning. No matter how important you are, Claus, and you know I often refer to you as an expert, and we have this just get the pipes in the ground, just decarbonize thing among ourselves. So that's fun. And let's have a broader view. Europe, at least the world. What does this mean with these heat pumps? You have touched on it in different directions, but what is the perspective?
I would say one expect. I know that I'm Esbjerg, Morten, but I have also an outlook to the world.
Yes, exactly.
I think that the perspective is even much bigger than what Raymond have indicated, because I think heat pump will be really, really important also for sector coupling with industry, because there's a huge untapped need for electrifying industrial heat solution and industrial cooling solutions. So there is a huge impact on the whole green transition, but also on industries and extracting. When you go for carbon capture, these things, you still have some of these core competences that are with heat pump technology to get even that we can do carbon capture, or we can do electrifying of process industries, but we have to do it in an efficient way. And if we have to do it efficient, then we have to do it in many cases with heat pump technologies, because they are a better use of electricity. Even that we will see that we have more renewable electricity. We have to use it as a scarce resource. Also, renewables are scarce resources. So we have to utilize even renewable electricity in an efficient way. So I think we have only seen the beginning, and district heating, decarbonizing district heating networks is a no-brainer. But I think there is a huge untapped potential still there in the sector coupling, especially for industries, for getting combination of cold and heat production. There's a huge market out there and a huge need in the green transition.
Raymond, your comments to the European, the world perspective?
Yeah, absolutely. I can only agree what Claus just said. I think we have the greatest technology on hand. The technology is very old. It is very robust. It works and works and works, does a great job, and is utilizing the power in the best efficient way you can actually imagine. The only thing is why still district heating operators are considering other sources for their district heating networks is because of low prices, let's say, on gas, and high tax on electricity. And of course, if these are private companies, they want to do profit, and they have to look at the OPEX cost. But I think in the long run, if someone really means it to decarbonize and make this a better world, then I think there is no other way to go after heat pumps. Absolutely not. And so I have a saying which comes from the lyrics from Robbie Williams. If you really want to change the world, not let love be your energy, but let heat pumps be your energy. And I think people have to consider this, and economy ecologically and environment over profit making. And I think we have to make this change and to think a little bit about this, because we've got only one planet.
There's a tradition in these podcasts that I leave it to both my experts, or maybe three experts, to give a one-liner. But I think we will finish off here with the one-liner from Robbie Williams, nearly adjusted by Raymond Williams, I don't know. Let heat pumps be your energy. Thank you very much, Raymond, and thank you very much, Claus, for taking part in that and explaining to me and all the listeners about the good things about heat pumps. And thank you also for the new word, a mega heat pump. I think it's a fantastic thing. I will use that in my work when I promote district heating. Thank you, guys, and hope to see you soon.
It was my pleasure. Thank you very much. Bye-bye.
Thank you. Bye.